Hello, I'm Elizabeth Brown with the International Board of Safety Professionals. Today, we will have a presentation on hazard recognition and assessment. Part one of our presentation today will be on hazard identification. All right, first let's talk about what is a hazard. It's something that's commonly discussed and referred to, but a hazard is something that essentially can cause harm to an individual. And in this particular presentation, we're focusing on hazards in the workplace. So a hazard can be a substance or a process that could cause harm. It's important that in workplaces we conduct comprehensive risk assessment so that we can understand what hazards or what potential hazards or situations can occur that could potentially cause hazards to individuals in the workplace. So we want to conduct these risk assessments in order to try to put preventions and controls in place to prevent these hazards to employees. All right, so after we identify the potential hazards, then we evaluate and acknowledge the risks that exist, and then establish those controls, like we mentioned, to ensure that we have a safe working environment. So examples of things we might consider when conducting these hazard risk assessments. We can look at the process in the work environment. So are there chemicals involved, such as paints, solvents, acids? Is the environment noisy? Would we need to conduct a noise assessment to ensure that the noise levels are within the appropriate levels according to OSHA? Or do we need to provide hearing protection? So we need to, this allows us to understand in a whole level, what are the hazards that an employee is at risk to be exposed to in the workplace? You know, do we have elevated heights? In a general industry setting, any worker that is exposed to a height of 4 feet or more should be guarded or protected against fall. If they're on scaffolding or ladders, there are some exceptions to that, and the heights are different in which a worker can be exposed to those heights, but we have special work practices we must follow. Also, does the process generate any type of airborne substance that an employee could breathe in, such as dust particles, gases? There might be chemical reactions that occur, like a very common one is with welding. Welding fumes can have toxic substances in them. For example, hexavalent chromium is a substance that occurs when welding is performed on stainless steel. And so we would want to further evaluate any of these types of hazards for the level of risk that is associated, and then also determine what protective measures we can provide employees to make sure that they're not getting harmed in any way from our work processes. All right, so in our hazard identification, questions we want to consider: what are the hazards? That are just, you know, those are the things that are probably obvious to the work environment, but we have to look at what else could go wrong, you know, not just our typical normal working environment, but also if we're in a startup or a shutdown or a maintenance type mode, you know, what else could go wrong in the situation? And I'm going to pause here really quickly. Sorry about that. I had something making a noise in the background. Okay. So what could go wrong? What are the chances of it going wrong? So we have in common risk assessment a risk probability matrix. So it's what is the risk? What is the outcome of the hazard? What is, is it a really high level consequence in terms of, high level outcome would be a serious injury, potential death or loss of life, environmental damage, or examples of consequences. And then what is the probability or the chance of that occurring? So those are some scenarios that we look at in terms of this matrix of what is the probability of it occurring and what is the consequence that it would occur. So when we look at that matrix, the risk, then the hazards that have a high consequence, so serious injury or potential loss of life, and then also a high probability that it could occur, those are the hazards that we need to focus on first and look at with a high level of priority of ensuring that we have hazard controls in place for employees that are working in those jobs. All right, so here's a great flow chart showing us the hazard identification and risk assessment procedure. So we've started with a system or a process description, and I'd like to note that doing a hazard assessments is a great opportunity to work in a team to assess hazards. So working with the operator, as a process engineer, a manager, as well as a maintenance person, and then also a safety manager is a great minimum team to have when we're looking at a system. That way we're able to identify hazards every step of the way. I've often encountered where teams are formed to work on hazard and risk assessments, and they don't involve the operator in these processes and in these assessments. And to me, the operator is the person that knows the most on how that position runs, what are the shortcuts operators might take, what are the hazards that they're actually facing every day. So I think that's important that they're included at least at some point along the way. So again, we have a system or process description. Then we identify the hazards for each step of that process. And then we might also have different scenarios identified. So we might have a scenario of, say, a filter change out for a baghouse on a painting line. That's a specific scenario that doesn't occur daily. Oftentimes it occurs monthly, quarterly, or annually. But those are scenarios that we need to ensure that we are considering, not just our normal everyday process. Then once we have all of these things broken down, then we look at the accident probability and then the accident consequence, as we discussed on the last slide. From that, we determine the risk associated. And there's always going to be a level of acceptable risk. Those might be those low level outcomes or consequences, and then low chance of probability. Because unfortunately, we do want to get to where we have a risk or hazard acceptance of 0. And there are companies that strive for that. And if that's the case, then every risk that we have will be a no, that no, this is not an acceptable level of risk. And if that's the case, we would go to modify our process or the physical process itself, like the physical equipment. That might be adding a guard, adding some type of engineering control. We also could modify the process operation. So that would be more of an administrative or work practice control. We may modify our emergency response systems. We might add PPE. There's all types of things we might do to modify the system itself to hopefully change the risk or eliminate the risk of that hazard occurring. But if we do have a level of risk or hazard acceptance and the hazard passes the test for that and it's a low level and we accept that risk, then we would build or operate the system or continue to operate that process. Other types of hazard identification methods. So again, working as a team, we've talked about the process itself, but once we've written out the system description, then we need to have a process of identifying hazards. Again, working with the team, having each individual in the team complete their own review, whether it's using a checklist, which is a great thing to have. The OSHA has a good hazards checklist, and there's quite a few that are available that allows individuals to assess the system or process and consider the list of hazards that are commonly seen in workplaces and to consider if that's a hazard in their workplace. Hazard surveys, there's a range of those from just a basic inventory of hazardous materials to actually having a comprehensive evaluation that can be very complicated. Similar to like the Dow Index, which serves as a formal ranking system of companies. This is very similar like an income tax form. It's a very complicated system that offers penalties for hazards and credits for safety equipment and procedures. We also have the hazard and operability study that's a study that's frequently used, where we have a free flow of ideas within a controlled environment. This allows that team to work together to propose various events related to a particular piece of equipment, and participants evaluate and talk through the possibility of that hazard occurring and what the frequency might be, and then those resulting risks would be assessed. We can also use a less formal approach of just kind of a safety review. The outcomes of those do rely heavily on the experience within the group. So while those might be effective, using a more formalized HAZOP study or checklist may be a better fit for a group that might not be as experienced in doing these hazard identifications. All right, factors affecting selection of control methods. So what is the phase of the process in plant development? What is the purpose of the hazard evaluation? The first bullet point there mentions plant development or process development. Ideally, these hazard assessments occur prior to a process being implemented, or say we have a new product that we're creating a line for and adding into a plant. This would be a part of the planning process. But I often work with companies where this has not occurred, or they have had an injury or an incident that they want an expert to evaluate. And you may go in as a team and assess the risk assessment on a process that's already in place, and that's fine too. We need to assess these hazards, but again, ideally it would occur prior to the implementation of a process or a physical plant facility. Other factors affecting the selection of the control methods would be, what are the potential consequence levels? What is the complexity of the process or the plant? And what are the information and data requirements of the methods? Classic limitations of hazard evaluation studies for the team to be aware of is completeness. There's never a guarantee that we have identified all potential situations, causes, and effects for accidents that can occur. And we are almost always or always, dealing with human beings, and there's always this risk of human error that can occur, even if we identify all of the hazards, we put all of the safety rules in place, we provide all of the physical equipment and guards, we provide training, we provide personal protective equipment. We still have to rely on a human being to follow those rules, wear their personal protective equipment, use the equipment and the controls in the manner they've been trained to do. And unfortunately, that doesn't happen 100% of the time. Other limitations are reproducibility. So there are various aspects of these hazard evaluation studies that can be sensitive. Different experts may use identical information, and they might generate different results by analyzing the same problem. So that's going to be more of a, this is a qualitative data analysis where is subjective. It's going to be and based on the expert that's analyzing the information, based on their knowledge base and based on their past experiences of what the outcome may be. Also, another issue might be inscrutability, which is just the inherent nature of some of these hazard evaluation techniques, can make the results difficult to use and understand. So the experts need to be able to facilitate the understanding of this information to the workers and all key stakeholders so that they're able to understand the risks associated with their job and how to control them. Also, relevance of experience. So a hazard evaluation team may not have the appropriate base of experience to assess the significance of potential accidents. We spoke on the last slide about why this is where it can be helpful to use a HAZOP study or a checklist to help guide a team that's less experienced to create the best hazard assessment that they can. Again, we mentioned with inscrutability that these situations can be highly subjective as well. Hazard analysts must use their judgment, which is based on their past knowledge, training, experience, to determine whether a problem is important and to measure that level of risk. This is why, again, that it's important to use a team where one person may see a situation as not as important, another person might have valuable insight and experience to share with the team on why it is or should be a high level risk. All right, our process safety checklist. In general, I'm not a big fan of checklists for employees to use for because they sometimes can get in the habit of just checking boxes and not really actually doing, say, a pre-operation safety check on a forklift or a crane. But I do like the idea of checklists for our process safety in performing these hazard evaluations. The checklist provides a comprehensive list of potential problems and areas that would need to be scrutinized to determine what the hazards and the potential consequences are. And this just allows reviewers and operators to ensure that they've addressed all potential issues. These checklists also serve dual purposes, aiding in identifying design hazards also in the process design phase, as we spoke about, that this is ideal that we do this before the actual process operations begin. Checklists also that are specific to chemical processes can be extensive. They can encompass hundreds or even thousands of items for evaluation. So this can take a long time, but it does ensure that you have a comprehensive evaluation of these processes. The design of the checklist should be specific to the process and the general hazards of that process. So it's ideal if, say we have a a line where we're fabricating metal pieces to create a piece of equipment, that we would have a checklist that ensured that it regarded the hazards of welding and all the things associated with that. Checklists proved to be the most effective in pinpointing hazards that stem from process design, plant layout, chemical storage, electrical systems, and similar areas. Here's an example of some process safety checklists that would sufficiently demonstrate like the general layout of the facility, the physical building itself, just asking questions that might be easy to overlook. Then we come over and we have things laid out in different categories, process, piping. And when we're looking at piping, it's not just, or is everything labeled, but are the safety showers and eye baths required? Adding something about, are they labeled appropriately? Are sprinkler systems required? These are all examples of things that, especially someone that does not have experience in safety and hazard and risk assessment, this would be very helpful for them to complete this and guide them towards making an appropriate risk assessment survey. We spoke about hazard and operability HAZOP studies earlier. These begin with a detailed flow sheet, and we break that flow sheet into a number of process units. We would choose a study node, so a vessel or a line, and then we pick a process parameter. So flow, level, concentration, the pH, viscosity, reaction. And then we apply a guide word to suggest if there's been a possible deviation. If the deviation is applicable, then we determine possible causes and note any protective system that would be needed. We would also evaluate the consequences of a deviation, and we would recommend action. And all of this, we would, of course, have notes and a system where we're able to record all of this information. Performing these hazard risk assessments is very important for compliance with OSHA standards, as well as any company that may be seeking to have or continue to have ISO certification for occupational safety and health management systems, or any other type of health and safety management system. These are key to ensuring that you're addressing all risks and meeting the requirements of those certifications. All right, here's an example of a HAZOP table. These are templates can be found and then are also readily created using an Excel spreadsheet where a team could share and work on these together. All right, part two, we'll move into risk assessment. So why do I need to do risk assessment? So it is the employer's responsibility or duty to protect employees from harm. So under the Management of Health and Safety at Work regulations of 1999, a company must identify what would cause injury or illness in your business. So what are the hazards? They must also decide how likely it is that someone could be harmed and how seriously. So what is the risk? And then they must take action to eliminate the hazard, or if this isn't possible, to control the risk. So we've talked in the past about the hierarchy of hazard controls, and we always want to consider that hierarchy whenever we're looking at controlling a hazard from harming employees. So the first and most effective measure is to eliminate the risk, eliminate the hazard completely. So as I just did, hazard and risk can be used interchangeably, but there are key differences as pointed out here on this slide. So a hazard is the potential of a substance or process to cause harm to people. And then the risk is the probability of that hazard actually causing harm. So as this is a great example here of this picture of this cartoon shark. So a hazard is something like a shark in the water. A risk is a person swimming near the shark, or the shark swimming near a person, and that person being exposed to that hazard of the shark. So we would want to protect ourselves from the sharks, right? All right, so a risk. So let's look at this in a more quantitative level in terms of employee hazard exposure at work. An example, hazard of asbestos. Asbestos exposure can cause things like mesothelioma, lung cancer. It can cause something called asbestosis. So there's a lot of different processes where asbestos exposure can occur, and employees, if they're at risk of inhaling asbestos fibers, then those asbestos fibers get settled into the lungs. They're at a microscopic level, so we can't even really see that with our eyes. But they get breathed, they're respirable, and they get the employee breathes them in. The fibers get settled into the lungs, and then our bodies see that those asbestos fibers as foreign objects, and our bodies send an enzyme to the asbestos fibers to try to break them down, because it sees it as a foreign object that an enzyme should be able to break down, and then the body should be able to absorb. But unfortunately, that's not the asbestos. And silica, crystalline silica, works in a very similar way. Is such a hard substance that our bodies, the enzymes in our bodies, cannot break those down. So how we are affected by this hazard of asbestos is that our bodies, the enzymes, continue to try to break down the fibers, and we build up scar tissue in our lungs from that process. And that's why exposure to asbestos and that hazard, the outcome typically is not seen, and employees don't typically start showing symptoms of this exposure until 15 or 20 years after years of breathing in these asbestos fibers. So the risk of inhaling these asbestos fibers is higher when we are working around asbestos boards that's in poor condition, or being disturbed or broken, or working around any other things that have asbestos or crystalline silica in it. So if we have employees or plants, companies where there is still asbestos containing material in the building, we must take caution to ensure that we are following processes to remove any asbestos boards that are in poor condition, or being disturbed, or get broken, and that we also have warnings to employees about this material being in the building. So with risk, we have levels of risk. So levels of risk may vary among different worker groups. If an example of a differentiated worker group would be an expectant mother, because they're exposed, some certain exposures may harm the fetus, individuals with disabilities, and also new employees, because they don't have the experience and the wisdom to know about all of the hazards that might exist. It's very important that we do worker training with our new employees, but this doesn't mean that we've always fully explained, or that they've fully experienced the risk that may occur in their job. Also, when we're evaluating respiratory and hearing hazards, the typical assessment involves comparing individuals' level of exposure with established occupational limits to determine the associated risks. So OSHA has guidelines for common air and respiratory hazards that they consider when they are evaluating the worker exposure. A risk, and again, a risk is the probability of a hazard actually causing harm. That's a really great direct way of looking at it. So you can see this worker here that has a jackhammer. That is obviously a very noisy piece of equipment. And even though this employee might be fully protected against those hazards, the employee that is, in the vicinity of that occurring may not consider putting in hearing protection, and they might be affected by that hazard. But obviously the operator himself would have the higher probability of the hazard causing harm. All right, so how can I find out information about hazards? So let's say I recognize a hazard. I've conducted a workplace inspection using my hazard checklist. Conducted a walkthrough of my site. We want to always look at, when doing hazard assessment, evaluating the work task and how they're executed. So what is the operator doing and how are they doing it? And then also evaluating the equipment that's utilized by the workers. Is it properly guarded? Looking at all of the potential things. So how is the work being done and the equipment, finding and seeing those hazards as well. We also want to analyze the design and arrangement of the work area. This is also helpful, and it can occur when we're looking at how the work tasks are being executed. So how are the workers working, and analyze the design. And when we were looking at analyzing the design and arrangement of the work area. So that means that we're looking at, is a worker having to bend over repeatedly? And maybe we're able to put that work on a table so that it's at waist height. Are workers having to walk over cords or walk an extensive distance that's unnecessary? Then maybe we're able to arrange the work area in a different way and put protections in place. Finding information on hazards, I always, when training employees, trust your instincts. If something looks like it might be dangerous, it's worth evaluating further. It's worth asking a supervisor, going to the OSHA website, going to a NIOSH website. There's a lot of resources out there about what things are hazards and how to control those hazards. So in this picture here, we see some red circles around some different hazards. We've got an overhead crane. So I can, if I want to find out more information on the overhead crane hazards, I can go to OSHA's website or go to my supervisor and find the specific regulations and guidance on that. To the right of the overhead crane, we have a worker bending over at the waist just to pick up something heavy. That can cause a severe back injury that could harm that worker for the rest of their life. And we have, a lot of different examples here from, again, workers carrying things. We have welding occurring. We have a worker on the bottom. That's a picture smoking near a compressed gas cylinder. Things like slips, trips, and falls are very common hazards. We see towards the right of the picture a worker about to come up on what looks like a spill in the floor. We have workers on ladders. We have a worker standing inside a piece of equipment next to the worker on the ladder. This is an elevated work area, and potentially a piece of equipment that's not been locked and tagged out. So there's a lot of hazards that can occur there. So I encourage people to go to work with their eyes wide open, wide open to what hazards exist, what can occur, and what could be the consequences, and not just to keep walking and going about your day and ignoring it and acting like this is someone else's problem. Safety is everyone's responsibility and should be addressed that way. That way we're looking out for ourselves and looking out for each other. So again, just kind of looking at this hazard checklist, we can also can help us and guide us to look to see what controls we might need to put into place. Some hazards that affect the body, noise. So a continuous noise exceeding 80 decibels can damage hearing. OSHA requires that any company have a hearing conservation program for workers that are exposed to 85 decibels or more over an 8-hour time-weighted average. And if they are provided hearing protection, if they're exposed to over 90 decibels over an 8-hour time-weighted average. And then we also have a table of noise exposure and how much time a worker can be exposed where they need hearing protection. And then we have a peak noise level where noises must not exceed 135 decibels at any point in time without a worker being protected from that. Other types of health hazards are particulates like dust, mist, metals, fumes. Metal, plastic shards can be breathed into the lungs. Chemical splashes can affect the body. Chemical gases and vapors can be breathed in. Radiation, UV, and visible infrared can also be very harmful to the body and must be addressed. Where can I find more information on hazards? So again, we keep talking about this. We talk about our supervisors. We talk about the physical work environment, walking around, seeing things that may be issues. We have equipment, materials, and substances utilized in the workplace. So every chemical should have a label on it as to the hazards that exist with it. And then we should also have a safety data sheet for every chemical. And those safety data sheets have a lot of information on them, and really all the information you would need to address the hazards and the risk and potential risk to employees in order to, and it also provides first aid measures, potential personal protective equipment that may be utilized, as well as like work practice controls that the manufacturer of the chemical recommends. Additionally, we could look at the work tasks themselves and their execution, and then the work design and management. So all of these things, again, we're trying to address these hazards and look in a comprehensive way at all the processes within the company. All right, so what is a risk assessment itself? A risk assessment is an information gathering exercise that, again, it's great to do as individually, but to come back together as a team to create a comprehensive list of the hazards, the risks, and work together as that team to decide on what's the most appropriate controls for those hazards and risks. Risk assessments requires information on substances, chemicals, any type of health hazard an employee may be exposed to, the work processes themselves, so the location, the duration. An employee may perform a task once a week. It might be a maintenance or servicing of their equipment, and that might expose them to a different chemical than they're exposed to most of the rest of the week. That still needs to be considered, and that hazard needs to be considered and written down in that risk assessment, and that risk needs to be considered and controlled. The assessment of the levels of exposure, again, must be considered, and then evaluation of control measures must also occur. So we mentioned earlier about hazardous chemicals. OSHA requires, and also the United Nations have a hazard communication standard. And that this is something that is globally harmonized. So that meaning that essentially every country should follow these same standards that require each chemical to have a label and have a pictogram. As seen here, we have these 9 standard pictograms that communicate health hazards, physical hazards, and environmental hazards. So a chemical could have up to 3 of these pictograms for each of those categories. depending on, and we would choose the most severe hazard that could occur from being exposed to this chemical. So we have this skull and crossbones pictogram here. That means that an acute exposure could cause an immediate life or death situation. We have other health hazards are in the second row is kind of a picture of a man. I say it looks like a starfish in the middle of his chest, but it kind of looks like maybe an exploding bomb. But that means that an exposure can cause a change in your body on a molecular level. Like it could cause cancer, it could cause reproductive issues. So it's definitely a serious health hazard. And then our less serious health hazard is the exclamation point. These are generally things that might be cause sensitivity or an irritant to an employee. And then we have our physical hazards from the top row, from the left. We have like an O with a flame on top. That means something's an oxidizer, which means it can contribute to combustion. The next one to the right is a flame itself. So that means it's flammable, and that could be a flammable gas or liquid. And then the picture next to that is an exploding bomb. So that means it is explosive. On the bottom row on the left, we have some beakers and a hand. That means that's to indicate corrosiveness. The picture to the right of that is means compressed gases. And then we have a tree and a little fish. That's our only one environmental hazard. It means that it's hazardous to aquatic life. And then we talked about the health hazards. All right, so risk phrases. You can see these are definitions of chemicals as detailed in the CHIP 2 regulations. Some examples are like R1, explosive when dry. So that would be something very, very physical, very hazardous, or potential risk can be high there. R26, very toxic when inhaled. R35 can cause severe burns. R42 may cause sensitization when inhaled. R43 may cause sensitization when in contact to skin. And R49 may cause cancer when inhaled. So a good way to think about risk assessment is really management of risk. And risk management is a step-by-step process for controlling health and safety risks caused by hazards in the workplace. So I like to look at this risk management as a continuous improvement process. There is no starting point really, and there is no finish line. We are always, well, you can start with identifying the hazards, but we'll always come back to it too and restart. So we'll identify the hazards, assess the risk, evaluate and control the risk, record the findings, and review the controls. And a very healthy safety and health management system will be constantly reevaluating these hazards, reassessing the risk, reevaluating and controlling the risk, recording the findings, and reviewing the controls. A healthy system will do this on a systemized, systemic basis, quarterly or semi-annually or annually. And then also, of course, after any time maybe an employee brings up a concern or there's been an accident or a near-miss incident that may have occurred. So I always encourage employees of all levels to be aware of their surroundings, take personal responsibility over their own safety and the safety of others in the workplace. So again, if it looks like, if you wonder if it might be dangerous, it probably is, and you need to let your supervisor know, or you need to look into finding out what are the dangers or the risk here, and is this a hazard? So again, looking at how people work and how the plant and equipment is used for processes, examining the chemicals and substances, reading the safety data sheets, making sure that all of our containers are labeled and that employees understand what the hazards are and the risks are for using the chemical, making sure they're using the correct hazard controls, and the correct PPE if required. Continuously being aware of and identifying safe and unsafe work practices. Like we see in this picture here, there are quite a few unsafe work practices occurring. We've got a worker standing on top of two 55-gallon drums that are not stable or secure. There we have spills in the floor. We have someone bending over from the waist to pick up a heavy load. Those are all very unsafe work practices that should be addressed, and employees should be trained and provided the proper equipment to do their job properly and safely. Another proper way to assess risk is to look at our injury and illness logs to see what are, and also our near miss reports to see what accidents have occurred. What are the frequencies of those accidents? Are there any trends that we can identify that we need to address? And then also do the same thing with near misses. All right, so once we've identified the hazard themselves, we've talked about we need to assess the likelihood of the harm happening and what is the potential severity of the consequence. So this process involves, a risk probability matrix or some type of evaluation of level of risk. So we have to determine who might be harmed, how many people, how would they be harmed, and what measures are currently in place to control the risk if this is a process that's already in place. All right, part 3, controlling the risk. We've talked several times in this presentation about the hierarchy of hazard control. And this is a great pictogram that I like to refer to often, and that we see at the top of this hierarchy is an inverted triangle to demonstrate that elimination is the most effective way of controlling hazard and risk. So that is actually physically removing the hazard. Next, most effective is replacing the hazard by maybe substituting a chemical for a less dangerous chemical. The next most effective, if neither of those things are possible, is to provide engineering controls. So physically prevent people from coming in contact with the hazard. The engineering controls that are common are guards, barriers, things like that, physical protections that make a physical barrier between the employee and the hazard. Next, we have administrative controls. So we change the way people work. An example of an administrative control is a lockout tagout procedure where we require employees to follow a procedure where they have to physically put a lock on equipment before they and isolate the energy source going to the equipment so that a piece of equipment cannot be physically turned back on if they're performing maintenance or repair. And then lastly, in the least effective hazard control or risk control is a worker utilizing personal protective equipment. The reason why this is the least effective is because we still have the hazard existing out there. Personal protective equipment can never protect an employee from every hazard 100% of the time. And we have to rely on employees to wear that PPE and wear it correctly all the time. So we have the requirement that if we employ 5 or more people, it's mandatory to document your significant findings when you're doing your hazard assessment. So we must record our findings. So we must record what are the hazards, things that might cause harm, who might be harmed and how would they be harmed, and then what risk control methods are you using. You must review the controls you've put in place to ensure they're effective. So we can't just say, oh, we'll put this guard on this piece of equipment and then forget about it. You have to make sure that you review that guard's working effectively. They may no longer be effective. And this could be due to changes in staff, changes in a process, or changes in a substance or equipment that's being used. So we need to have a system in place that allows for a programmed review of all of our controls. Again, our least effective control method is personal protective equipment. It is designed to protect employees from specific hazards. So you have to demonstrate that you know what the hazards are, you know what the risks are, and you have, as an employer, specifically chosen these pieces of personal protective equipment because an employee needs it to protect themselves from the hazard. OSHA and other regulatory agencies don't want to see that you've just told an employee to wear a hard hat because other companies do. You have to justify the need for it. So remember, we have the 5-step risk assessment process. It's a continuous improvement process where we identify the hazards, we determine who might be harmed and how, we evaluate the risk and identify suitable and sufficient control measures. And then we also record and implement those findings. And then we're going to have a scheduled review of the risk assessment, and then also update as necessary based on situations that might occur, say an accident or a near miss or an employee complaint or referral. Okay, that wraps up our presentation on hazards in the workplace and our risk assessments and how to conduct risk assessments. I appreciate your time today, and we will see you soon. Thank you.